Hello everyone. In this video, I'm going to talk about various approaches you can take when you are optimizing for the database. So many times I have seen when people are optimizing for the database, they choose the last option that is of sharding by default. Maybe it sounds cool, maybe it's a fashion. There are many other options you can consider before moving or jumping into the last option because there are other options and people do use them all the time. So we'll explore all these options, not necessarily in the same order you would be applying in your own system, but this is something which we can try and we can understand that what are the various options which are present. So let's get started. The first thing first is what you can do is to have a better VM. I think that is one of the easiest thing you can do. That is, you increase the resources, you increase the RAM, CPU, SSD in your system or in your database. Nowadays, in fact, people do not use a physical VM. They use some service plan by Azure or AWS. So even in those cases, what you can do is that you can buy a better plan. So for example, if somebody is telling you that, hey, I have 100 million requests per day. So if you divide, it would come out to be roughly 1,000 requests per second. So there are many options available online who can help you with 1,000 requests per second. So definitely you can choose that. The second option you can choose is around adding the indexing. So indexing is a fairly old concept and fairly mature concept to be precise. Lot of people use indexing and there is a lot of theory available online that how to index, what are the pros and cons of indexing, what happens if you index too many columns and how it impacts the performance. So there are a lot of things already available online. You can go out and read. So many times, if you add indexing in a proper way and you understand the system well, then it will solve for you. That is, your queries will become faster and with the combination of one and two, that is having a better VM and indexing, you will get the job done. The third thing, if even the indexing doesn't solve the problem because the data is huge and you are still dealing with the latencies and the performance, then the third thing you can try around this is the partitioning. Now, partitioning is a bit different concept compared to sharding. So let me give you an example. Let's say you have a database and you have customers and you have customers from, let's say, both Delhi and Bangalore. And somehow you know that the people of Delhi do not have to do anything with the people of Bangalore. So, what you can do is you can give a command, you can run a command on the SQL database that, hey, can you create a partition on the column name city? So, what will happen is that whenever in the where clause there is a city column, the database would come to know that which partition to scan from. So overall, the the B tree has become smaller. So earlier you were scanning the all the cities, that is both Delhi and Bangalore, but with the help of partitioning, with the help of the this where clause, the database would get faster. It's like giving a hint to the database that now, instead of creating a big index, please create two smaller indexes, and that will help me to query faster. So, with the help of partitioning, a lot of problems can get sorted. The concept is similar to sharding, just that in case of shards, you maintain the partitions on your own. That is, you maintain the two databases, one for Delhi and the other for Bangalore, and that's how you get the job done. But here, it is provided by database. So within a single machine itself, they would have a separate dealing with the two cities, and in this way, they will have a faster queries. The fourth thing you can try is around the primary and the secondary databases. So what happens is that many times your system would either be a read heavy or a write heavy. That's how the most of the systems are. And if you are able to figure out that if your system is mostly read heavy, then what you can do is you can have one primary database with all the approaches mentioned in 1, 2, and 3, and then multiple secondary databases. And these secondary databases will get the copy of the data from the primary. So all the read operations can go to the secondary DBs and all the write operations can go to the primary DBs. And in this way, you will be able to get away with the performance impacts. So all the reads will happen from the secondary DBs and the primaries will have the insertion, updates, deletes, those stuffs. So in this way, you would somehow be able to get away and have a metric which is acceptable. And that also works for most of the people. And the last thing, if you say that, Anubhav, you don't know me, you don't know my system is actually a write heavy. I can't use just one primary DB for all the write operation. Well, in that case, you can go for the multi-master databases. Of course, multi-master database have their own challenges, especially around the conflict resolution, because what if there are two writes which are conflicting among themselves, but they have the approaches how to solve for these things, how to prioritize, which one to prioritize, etc. So those things are already there, and many times that can also be chosen. And well, if all these options of having a better VM, creating more and more indexes, partitioning, primary, secondary, or multi-master databases do not work, then you are welcome to use sharding. And then you are welcome to the world of sharding. It will open a lot of avenues for you because now you will no longer be limited to one single machine. You will have one machine for one city, that is Delhi. And then when you move to Bengaluru, you created one different machine. And if you move to Mumbai, you again created another machine. So you keep on having a new machine and the new database within that machine, and that database will work independently. And that will be very much scalable. Now, the problem with the last option of sharding is that there are a lot of things which you have to manage on your own. The first is that now you need to make sure that all the schemas across all the CPU are consistent. There are ways to do that, but this is something which is now delegated to you. Now it is no longer owned by the database. The second is that you lose. People say that ACID is bad and all, but losing something is something which you need to weigh in. That if you had a single VM with indexes and partitioning, you were getting that rollbacks, transactions, things like these. But the moment you move to shards and you want to have something cross shard, that is, you want to have something between Delhi and, let's say, Bengaluru. So the cross shard transactions is something which you will lose right away. That was there when we had a single machine because the database itself take care of that. But now you have two different machines. So now you have to manually deal with the consistency and the other stuffs. So you lose that. I'm not saying you should not lose it. There are times when you should definitely go ahead and not have such constraint, but this is something that you would need to manage and understand on your own instead of you delegating on the database. So that's all from my side. If you see in this video, we talked about various approaches. Many times it makes us sound cool and more intellectual to directly jump into the solution of sharding that create more and more shard, one shard for this, one shard for that. But there are other options already available. And for most of the people, these options do work fine. If you talk about the number of requests in order of 1000, 2000 requests per second, it's not much. And if you see the documentation of various databases, they do have a very high number in terms of what they support. And the same goes for indexing. So there are various types of indexes of various types of database engines. So there is P tree, P plus tree, LSMs. So there are a lot of things already there, and a lot of research has gone into it. In fact, when you query a database, there is something called as Bloom filter. Okay, let's not throw the jargons now, but there are a lot of research has gone into making sure that your queries are fast, and they apply a lot of heuristics and caching to make sure that you get fast responses. So if all these options do not work, then be our guest and use Sharding. But if you can get away with using other approaches, you should read about them. There are wonderful articles and wonderful content available on all of these approaches online. You should go ahead and read about them and then make your best choice. So that's all from my side for this video. Till the next time, bye.